Hey everyone, so we are going to be looking at a data science roadmap that if you're a beginner, it'll take you all the way from that stage to where you want to be to get to an internship or that role. And if you're already a data scientist and if you want to level up, it's going to provide a few of those points which you can leverage to get to that next stage. Because let's face it, there is ChatGPT, there is Gemini, and there's probably a lot more tools that are coming up as well, GitHub Copilot and these kind of tools, which are going to be really, really useful when you're doing the coding that requires a lot less thinking. And where you need to excel when we have all these tools is actually giving a broader view to your stakeholders or to the project team. So that is called end to end. So we are going to look at all these things, and in the end, I'm also going to give a few of the pointers which are going to be really useful in today's age when we have all these new AI tools coming up. So how can we stay ahead of it? Not even ahead of it. How can we leverage those tools to our advantage? So I've just got a simple workflow over here that we are going to work through. Now you'll see there are not too many parts to it, but then there we'll explore each of these parts in detail as well. So let me just open up what I have within Foundations to Data Science, which is the first step that you need to tackle in your learning journey or in your journey towards becoming a data scientist or an AI engineer. So here I've expanded out the fundamentals of data science section. Now you'll see there are a few of these topics that you need to be at least have basic knowledge of. So that is like topics like mathematics, which is essential for understanding data science and algorithms and even the models. And the same goes for statistics, probability, linear algebra, calculus, and computer science fundamentals as well. So with statistics, it's critical for making inferences, understanding the data distribution, etc. So if you have a data set at your disposal, initially you would run some sort of statistics on it to understand what kind of data you're working with, how are variables correlated to each other, how are variables correlated to the target, etc. And you also want to have a good grasp on probability as well. So there are quite a few of these algorithms, let's say causal inference and so on, where you need to understand probability, some of these statistical significance tests, etc. So that is where probability and a knowledge of that is going to be key. And of course, linear algebra is one of the most fundamentals, because regressions and classification, these are kind of the fundamental building blocks of a data science toolkit that you'll work with. So it's very important for machine learning algorithms, data transformation, etc. And calculus is used in optimization and understanding changes in data. And of course, you need some sort of computer science fundamentals, which provides you a basic understanding of how algorithms work, etc. Now, you don't have to go and become an expert at all these things to start with. So there are various free courses on YouTube or on other platforms as well, where they go and teach these things at a really, really deep level and intuitive level as well, so that you can understand some of these things. And my recommendation is to get a project that you can work on initially and go through this end to end, where you're understanding the foundations all the way through to delivering business value. And that is the best way forward to understand each of these topics. So let's move on to the programming skills that you would need. So here we have a few tools that you can leverage. So there is obviously Python and R programming. So Python is widely used. There are numerous libraries and for data analysis and visualization, it's one of the best tools out there, in addition to Excel, if you will. And it's very easy to build an end-to-end solution with Python, because you can get the data in, you can clean it, transform it, and build out an API that can be used by real people in your business. So a fundamental to Python and end-to-end implementation in Python is absolutely necessary. R programming, it's more popular for statistical analysis and data visualization. Most of the time what you'll see is most of these R libraries eventually get ported into a Python library as well. But having a good understanding and ability to work within R programming platform or environment is again very, very beneficial. And of course, the bread and butter for data science, data analyst is SQL. Now, there are various tools that are coming up where you just give it a data set and a prompt and it's going to give you the results. So you can use all these tools, ChatGPT, Gemini, and other tools to actually give you SQL, and you just go and execute it. But I do feel in this field that these tools are more there to help you and then speed up the process of what you're doing. Because at this point, it's not perfect yet. And even if it was perfect, you'd probably want to understand some amount of SQL to understand what is going on under the hood. But yeah, SQL is going to be really, really simple going forward, especially with the help that you're going to get from ChatGPT and other platforms. And the same goes for Python and R as well. So here is where you need to differentiate yourself. So you're not just focusing on learning just these tools or languages or how to go about write SQL, etc. What you want to focus on is end-to-end implementation. Because remember, with all these new AI tools coming up, a business is going to be looking to hire just one person that can do a job of 3 or 2 people, right? So in that case, what you need is an end-to-end sort of an application knowledge. So you're able to get the data, you're able to get to a solution that their customers, the business customers, can use. So in that case, instead of focusing on just these parts, what you want to do is get a good understanding of how all these work, but then always keep in your mind to have a broader knowledge of all the implementation stuff. And that is why we're going through this data science roadmap, because I'm going to give you all that things that you need and that I look for when I'm hiring someone new as well. So let's move on. Next, there is data structures and algorithms. Again, it's very, very important to learn these things, even though we have help and aid from AI tools. So this is fundamental for efficient data processing and problem solving. Next is object-oriented programming. It's important for organizing and managing complex code. So even if you do a simple Python programming bootcamp, and that is good, but then if they don't cover things like object-oriented programming, classes, and other things, it's going to be really tricky to build something that is really scalable and where multiple people on a team can work on it. But at this point, if you get a good understanding of object-oriented programming, if you're just starting out, it's good enough. Then there is also functional programming, and this is useful for writing clean and maintainable code, because you just don't want to copy everything from ChatGPT and then put it in a file and then send it across to your teammates, because that would make things very, very unreadable if the code that got output from the AI tool is not clean enough. So you need some level of understanding of how to go about tweak all these things so that you get the output that you want, but you're also efficiently doing it in terms of speed and accuracy as well, because you know the fundamentals of object-oriented programming, data structures, and functional programming, etc. Next, we'll move on to data collection and pre-processing. So here we have a data collection and processing step over here, and it's a bit of a longer one, but we'll get through it quite easily. So first is, of course, you need to have some knowledge of the data, where you're getting that data from. So web scraping is a good example of getting like unstructured data from the internet. So techniques for extracting data from website is going to be key over here when you're doing data collection. And web scraping is not the only point. There's also APIs, which are officially given by the company that you're getting the data from. So this allows interaction with external systems and data sources. So if you're comfortable with getting data or posting data, that's good enough over here. Next, you need to move on to data cleaning and pre-processing, because not all the data that you get can be directly uploaded into your own systems or databases. You need to do some sort of cleaning and normalization or validation, etc., before you do all these data science work on it. So that's where it's very crucial for preparing raw data for analysis. Next, you have what we traditionally call as extract, transform, load, which is just gathering data, extracting data from here, and then cleaning, which will be transform, and then loading it into your own database as well. And next, we also can work with data formats. So if you're working with, like, let's say a company is giving you a file in an SFTP format and it's a CSV file. So you need to understand how different formats are stored and how you can process them and how you can exchange data as well. And dealing with missing data and uncertain data is again one more thing which is kind of crucial at this point, because there's more and more data, but then there's more and more cleaning that you need to do to get that data into a format that you can ingest into your own system. So all these things are all separate blocks which you can spend a lot of time understanding and tweaking and playing around with. So that is all you can get in data collection and pre-processing, and having a good data to start with is going to be the key. So here you will want to at least get an intermediate knowledge, if not advanced knowledge, in how to go about handling all these things, because it's going to make you a more versatile data scientist who can work with different sorts of data sets regardless of where the data is coming from. Now, you might be also thinking there are data engineers on your team who can help you do this. Now, that is good if you have privilege of working with data engineers who will be able to extract the data and load that and transform that into a format that you can work with directly. So some teams have that privilege, but if you don't have that in your team or in an internship or in a startup that you're working with, ability to wear multiple hats in that scenario is going to be the key. And that is probably what the business owners or the stakeholders are looking for when they're hiring as well. So it's good to have all this knowledge. Next, we have data analysis that we can move on to. So within data analysis, you would need to get comfortable with descriptive analytics, exploring data, and etc. So within descriptive analytics, it just summarizes an understanding of data features. And here, it's mostly about what happened in the business in the past. There are three types. So there are descriptive and predictive and prescriptive analytics. So if you're comfortable with all these three, it's going to put you in a good spot. And of course, that is where you need to be if you're doing a data science roadmap or if you're becoming a data scientist. And one of the key things that you want to do is obviously exploratory data analysis when you get hold of a data that you want to build models on top of. And here is where the data visualization techniques is going to really help you out. So because you want to investigate what kind of data that you're working with and ability to chart it or put that into a format which is visual and which is a bit more easy to understand is going to really help you out. So having a good grasp on the basics of visualizing data like bar charts, comparison charts, line charts, area charts, and box plots and other things is going to be really useful. Next, you also want to get hold of statistical hypothesis testing as well. Now, this method is used to make inferences and test the assumptions, because whenever you're starting a data science project, you are always starting with an assumption, and having good ability to do power analysis or do statistical significance tests and do build an experimentation is going to be really, really key. And that is where you need to have a good understanding of statistical hypothesis testing. Next, you also work with discrete and continuous distributions as well. So depending on the type of data that you're working. So having a good knowledge of distribution is key over here. And of course, correlation and regression analysis is going to be another key, because there are a few algorithms which have some preconceived assumptions within them. So if you're working with regression, you need some sort of collinearity or correlation between the input variables and the output variable. So if you're thinking about all these things, you need to have a good understanding of how to go about finding correlation between these two. Is a simple correlation matrix enough? Or do you want to go in and do an ANOVA test or a chi-square test to find these correlation? So these kind of things you need to have in your toolkit so that you're able to immediately go and say, hey, this is what I'm going to do. This is what I'm going to do next, right? So that is all about what you want to learn when it comes to data analysis, or when you're evaluating a course or a package that you want to purchase to become a data scientist as well. So there are various free courses online as well, but yeah, if you go through these roadmap and understand what you want to learn, you can go through the curriculum of what this new course and then go with whichever is the best for you. Next, we are getting towards machine learning, advanced statistical techniques, etc. And within this, there are a few types as well. There is supervised learning, which are algorithms for predictive modeling with labeled data. So you have a good way of building models on here. And the opposite to this is unsupervised learning, where you don't have labels. So if you take an example of predicting if a credit card customer is going to churn or not churn, or if it's going to default or not default, so that data set is considered supervised, because you usually have a previous data set which is already labeled with if the customer has churned or not, and you're going to build data off of it. But if you think about unsupervised learning, where you just get a dump of data, and let's say you're doing clustering analysis, right, where you don't have any labels attached to those customers, but you just want to find out what kind of clusters you can build out of these customers' data that you have. So those are kind of the two different types that you have in learning algorithm. Next, you also have reinforcement learning, which is algorithm for decision making and optimizing actions. And of course, few of the more advanced ones like neural networks and which is advanced algorithm for complex pattern recognition. There's also model evaluation and validation, because once you do build all these models, you want a way to assess the models, and you usually want to go with something that is pretty standard and understandable. Because one of the things is, if you go with the complex neural network that you build, you want to understand how is it working internally, and because it has a lot of hidden layers and etc. There are various techniques that are coming up where you're able to go with model explainability features and try to understand what features are adding more value to the output model, etc. So those kind of things you would need to understand when you're doing machine learning. And of course, you also want to consider overfitting and bias variance trade-off, etc. Balancing model complexity to overfitting, to avoid overfitting and underfitting, is going to be the key. Because if you have a test data and you build a model on it, and if you want to get like really good accuracy on it, you tweak all these norms and then you get really good accuracy, but then you realize you overfit that model because when a new test data comes in, it's not able to generalize, right? So those kind of things is another key point that you want to understand in machine learning as well. You want to have a model that is a bit more general. So when it comes to validating new data, it's able to perform well. Next, we have advanced statistical techniques. So within advanced statistical techniques, there is obviously the Bayes method, which is probabilistic methods for statistical inference. There is, of course, also frequentist method as well. Next, you also want to understand the time series analysis, because most of the data today is time series, but then you might be working with non-time series data as well. But if you're looking at doing some sort of sales forecasting, etc., you probably want to do time series analysis. There are things like anomaly detection, association rule mining, multivariate statistical analysis, etc., which all have their own application. And of course, causal inference as well, which is a huge field in its own, where you're trying to find the cause and effect. So it's another statistical technique which is really, really beneficial in so many different applications, like medical applications, where you're giving a treatment, and if you find out if that treatment was statistically significant or not. So those kind of tests use a lot of causal inference learning as well. So that is another advanced statistical tool that you want to be familiar with. And of course, you have these association rules like recommendation engines, or you want to find out if a person bought one product, what other products can you recommend to that person? So you can do like associated rule mining and find out all the historical information of all the other customers who've done similar purchases. And this is nowhere just the final list, but it's good if you have a good grasp on all these things. But again, what I recommend you do is get an understanding of all these things, but then work on a single project that you can go really, really deep into. Because when you're doing an interviewer is not going to ask you all the questions about all the different algorithms. They're probably interested in one problem that you've solved, which you can really, really understand at a very deeper level that no project or given to you online in these courses can. So that requires you to do a lot of research on your own and try to get an understanding in that industry. So I would say pick out an industry that you're interested in. Is it healthcare, education, payments, finance, whatever it is, and try to go in with a project which you can go as deep as possible and try to build out some sort of domain knowledge and expertise, and then apply for an internship or a job or switch of a role in that industry's company. And that is where you're going to be really, really good at and have an upper hand in the interviews. Next, we also want to understand big data technologies, because so far we've looked at statistical analysis, machine learning algorithms, etc. But one of the key things is also a big data technology knowledge as well, because there are things like Hadoop and MapReduce, Spark and Hive. So some of these are like data engineering stuff, but then having a good grasp on how all the systems are performing is again going to give you that end-to-end knowledge, which is going to be the key going forward with all these AI tools that are coming up. There's also NoSQL database, which is an alternative to relational SQL databases. Then there is stream processing. So if you're getting data in a streaming format, let's say you are a game development company and you're getting all these events in a streaming format into your analytical platform, and it's your job as a data scientist to build models on top of it. So how are you going to work with the data that's coming in? So it's not just about building a model, but then you're also working in with the data engineers, or maybe you're the data engineer as well, to get a good analytical output out of these stream of data. Then there's also distributed data processing. So if you're working with petabytes or even bigger data sets, how are you going to manage all that and run a model which you can get output within a few hours or days, if you will, instead of waiting for weeks and months? So you need distributed data processing in today's world, because the computing is there, and why not use it? Then there's also cloud computing for big data. So if you are able to understand the services that are provided by, let's say, AWS or GCP or Azure, etc., then that's going to make you that much better data scientist. So get a good grasp on big data technologies on your roadmap if you're trying to become a data scientist. Next, we have artificial intelligence. Here again, getting a good grasp of the fundamentals of AI and where this field is headed to, that's going to be a really good place for you, because you need to get basic principles and techniques that are used in AI. And as a data scientist, I guess the next common progression for you, if you prefer, is going to be an AI engineer. That doesn't mean that everyone in data science is going to move towards AI, but there are specific fields which are going to benefit from AI tools that are already coming up. So maybe the company is looking to build a fine-tuned system or a RAG model, etc. So you need to be familiar with some of these terms, and having a good grasp on artificial intelligence, LLMs specifically, is going to be really good. There's also AI programming, writing algorithms and software for AI. There's, of course, machine vision or computer vision, techniques for enabling computers to interpret visual data. Natural language processing, so this is huge in LLMs. So methods for processing and understanding human language. There's, of course, robotics, programming and designing intelligent machines. So there are various robotic applications, which is huge in the field of AI. And if you think about like self-driving cars or these big machines that do all the job within industry, production line, etc. So this is going to be key. And then, of course, you also want to learn about AI ethics, addressing the ethical consideration in AI development as well. Next, we'll move on to databases and data visualization tools and domain-specific studies as well. So we briefly touched on NoSQL SQL databases, but here we have a separate section on just looking at understanding the databases. Now, you might say, I'm doing machine learning or data science. Why do I need all this? Like I said, if ChatGPT and other AI tools is going to help you with a lot of modeling, etc., then a company is probably looking for an end-to-end engineer. So this is where it's going to get really blurry between the roles of analytical engineer, data scientist, data engineer, analyst, etc. So having a good grasp on all the technologies is going to make you so much better when you're going for that interview. So, of course, understanding relational databases, a database design is another key, because if you're pulling some data out of database to do your modeling, you need to understand what kind of schema it was used in building those database tables. And having a good grasp on SQL and advanced SQL is going to really help you there. And understanding entity relationships, diagrams, etc. is again going to be key. Data warehousing is another thing where a lot of data is going to come into a data warehouse, which is, I guess, used for analytical purposes. So having a good understanding of what is the difference between OLAP, OLTP within these databases is going to be key as well. And of course, database optimization, because you're pulling out data, but then you don't want to bring the entire database down because you're pulling out so much data. So how are you going to optimize the queries that you're going to do against the database in your journey is going to be key as well. So next we have data visualization, and within that there are tools like Matplotlib within Python, which is going to help you with visualizing the data that you're working with. And of course, you might also have tools like Tableau or Power BI, etc. But if you're doing some analysis within Python, then Matplotlib, Seaborn, Plotly are really, really good tools, which are very visual as well. And it's very easy to get set up and run. If you're doing in JavaScript, there's also D3.js. And like I mentioned, Tableau and Power BI are all these tools which can help you with data visualization. I would recommend you try out either Power BI, Tableau, or Google's Data Studio as well, or Looker Studio nowadays, which is going to really help you with understanding some of the basics of charting if you've never done data visualization in the past. Because just playing around with data and building some bar charts or time series charts is going to really help you when it comes to working with, let's say, you're doing your plotting in Plotly.js in your notebooks, that's going to be really helpful because you understand what kind of visualization you already want to work with. Or even if you don't have access to those tools, just start with Excel, where you're able to build simple tools. And that is really good enough to get a really basic understanding of these data visualization. Next, we have tools, platforms, and libraries. Again, if you're working in Jupyter Notebooks, which is Python, you can interactively do coding and sharing the documents, and there's live coding as well. There's Pandas, NumPy, and Scikit, which are all Python packages, and these are essential for data manipulation, machine learning, etc. There's of course TensorFlow and PyTorch, libraries for building and training neural networks, deep learning models, AWS, Google Cloud, Azure, etc. So these are all cloud platforms where you can do distributed computing or host your notebooks and work even more efficiently. There's of course Docker and Kubernetes as well, which is another key tool which often get missed out by data scientists because it's considered more of a data engineer or a software developer tool. But having an ability to build a model in Python in a notebook and then wrap everything up into an API that can be hosted on a serverless container service on AWS or GCP is so much more powerful because you have immediate results. You don't have to worry about having all the code which is there. The work is done, but how do people outside of data science team or yourself are going to use these tools, right? So that building a Docker container APIs is going to be really, really beneficial. And of course, Git and version control are just good practices. So finally, we have a domain specific studies. So here I've put a few of the domains here. So there's bioinformatics, econometrics, etc. So bioinformatics is applications of data scenarios working with biological data. Then econometrics is statistical method applied to economic data. There's of course social networks, quantitative finance, and business analytics, which is more common, and Internet of Things data analysis as well. So those are some of the domains which is not in any way exhaustive list, but work with it to see what kind of domain that you are interested in. So that is the roadmap that we have here so far. Have a go through this, and I'll share a link for where you can find this and download it and keep it. And I'll see you in the next video.